Hello students. Welcome to Module 4. Here, we will discuss how we utilize the measurement unit to understand the magnetic field's effect and how the gradient field has an influence on MRI. Let's go! The time-varying gradient magnetic field in MRI is critical for providing spatial information. The static magnetic field aligns our hydrogen nuclei and determines a regular precessional speed of hydrogen throughout our volume, as shown in Figure 1. This is because resonance is affected by the precessional speed of hydrogen. When triggered, the time-varying gradient magnetic field changes the hydrogen's precessional speed in the direction it is activated. 2. Gradient coils may switch on and off quickly when activated. This generates an alternating magnetic field, and Faraday's law of induction can create an electrical current in our patient. We measure magnetic field effects on our patient in dB/dt. Here, D means change in, and B means field strength. T4 time. We measure the static magnetic field change over time to estimate the time-varying gradient magnetic field. Now we will look into details of how the gradient field has an influence on MRI. It is critical to recognize that the time-varying gradient magnetic field supersedes the static magnetic field. To put it another way, the gradient magnetic field overlaps the static magnetic field. 2. The gradient coils are situated in the gantry around the patient, and when triggered, they enhance the magnetic field alternately on each side of the patient. This indicates that near the isocenter, the time-varying gradient magnetic field has minimal influence, while at the patient's peripheral, the time-varying gradient magnetic field has a large effect. 3. The Golay or saddle coil and the Maxwell coil are the two types of gradient coils utilized in MRI. A magnetic field supersedes the static magnetic field when an electrical current is sent via these coils. This will produce a shift in hydrogen's precessional speed in the desired direction. Let's see how sagittal and coronal pictures are formed in MRI. A distinct plane of imaging will be created depending on which gradient coil is triggered. These are referred to as physical gradients. Z, Y, and X are the three physical gradients. 2. The Maxwell coil is triggered in the direction of our table movement or in the z-axis. This will enable the creation of axial pictures. The Golay coils are used in the X and Y coils. 3. The X coil is turned on the x-axis. This means that the magnetic field will shift from right to left, resulting in sagittal pictures. 4. The Y coil is turned on the y-axis. This means that the magnetic field will shift from anterior to posterior, resulting in coronal pictures. We have conceptual gradients in addition to physical gradients. Let's find out how it differs from physical gradients and what it can do. The logical gradients are utilized to specify which gradient coils in a pulse sequence diagram are triggered to fill our K space. 2. The slice selection gradient corresponds to the image's desired plane. As a result, if we want to generate an axial picture, we will activate the Z gradient coil. The X gradient coil would be engaged to provide a sagittal picture, and so on. 3. This suggests that the physical gradients coincide with the slice selection gradient. It is also vital to recall that the patient is exposed to the resonant radio frequencies when the slice selection gradient is activated. The slice thickness produced is affected by the slope of the slice selection gradient. Thinner slices will result from a steeper slice selection gradient. What are a phase and frequent encoding gradient? First, we will start with the phase encoding gradient. Following the conceptual gradient, we must choose a location in our K space to begin populating with data. This is accomplished by turning on the phase encoding gradient. The slope of the phase encoding gradient amplitude determines the amount of resolution in our image. As a result, a steeper gradient slope produces higher resolution photos. Then we have a frequency encoding gradient. We shall activate the frequency encoding gradient at the echo time, t. The slope of the frequency encoding gradient will have an effect on our picture as well. A reduced field of view will result from a greater gradient slope. It is vital to note that gradient activations are more intricate than what is covered in this chapter. This is sufficient for the purposes of MRI safety. Let's look at the concerns of gradient fields a patient can experience. The dB/dt of the time-varying gradient coils determines this. Nausea, dizziness, and nystagmus are common symptoms in the mistor environment due to fast-changing gradient activations, uncontrollable eye movement. The potential for arrhythmogenesis is also evident during the activation of the time-varying gradient. This is the most serious issue for patient safety during an MRI session. If the time-varying gradient magnetic fields harm our patient's diaphragm, heart, or brain implants, this might pose a serious risk. This is quite rare to happen in patients. Patients' hearing safety. Concerns about the patient's hearing safety are also significant. The FDA limits MRI patients to 99 decibels, yet hearing protection is required because MRI equipment may exceed 140 decibels. Headsets or earplugs might be utilized to minimize the decibel level during an MRI operation, 1030 dB. Noise reduction ratings are assigned to earplugs. The noise reduction rating is between 25 and 33. The number of decibels was lowered for each noise reduction rating by subtracting 7 and dividing by 2 yields. As a result, a noise reduction rating of 25 equals 9 dB. Let's see how spin and gradient echo can be used by the technician to reduce worries. A technician can change their settings to alleviate worries about time-varying gradient coils. The pulse sequence that a technician selects can have an impact on these consequences. Because a spin-echo pulse sequence uses RF pulses to excite and refocus our hydrogen nuclei, it is not as gradient coil intensive. On the other hand, the gradient echo pulse sequences employ an RF pulse to excite our nuclei but use gradient coils to refocus our hydrogen. In MRI, echoplanar imaging produces the quickest gradient coil activations. As a result, this pulse sequence will have the most time-varying gradient coil detrimental effects. Click the quiz below. Once you've passed the quiz, we'll meet you back here for the next module. Click the quiz below. Once you've passed the quiz, we'll meet you back here for the next module.